Afternoon, students. We are next going to study about the next section of vectors, chapter 21, vectors. So you in the previous class we have introduced what a vector. Okay, I think all of you listened to that class, and I hope all of you understood what a vector is. Okay, and this is just an introduction to vectors that you have studied in the previous class. Okay, so vector is a, you know what are vectors. They are yes, magnitude. It has magnitude and direction, and those vectors which are example in physical quantities, we have examples like velocity, acceleration, force. They have also magnitude and also they have direction. Okay, so that is all vectors in physical quantities, and that are just some of the examples that has been given in this section. Okay, this page. Okay, and that arrow is convenient to draw. That just an introduction that we have studied in the previous class. Okay, so the next section is multiplication of vectors by scalars. So you know what is a scalar. Okay, scalar is a magnitude. Okay, it has magnitude but it has no direction. So what multiplication of vectors by scalars? Let vector a be a, okay, vector a be a vector, and m into a, okay, m given scalar, then the symbol m into vector a, okay, m into vector a, which is called the product of vector a by the scalar m. Okay, it is vector a is multiplied by the scalar m. Okay, such that it has, if it is said to be a vector, m into vector a is said to be a vector. It has two conditions. What are that? Yes, the support of m into a, that means if we draw the vector, then the support m into vector a is the same or the parallel to that of vector a. We can draw vector a, okay, and if we draw m into vector a, then that figures, okay, that figures should be same. Maybe it may be same or it may be parallel. Okay, that is the support. And next is the length of m into vector a, which is given by, you know what is the length magnitude, modulus of m into vector a, that is m into, yes, modulus of m into modulus of vector a, that is the length of m into vector a is m times or minus m. Modulus means it may be m positive or negative. Okay, so m times or minus m times that of a, but according as m is positive or negative, it is according to m is positive or negative. Okay, that is, and some characteristics, some results has been given there. That is this, you just go through that. It is not as important, but some problems may be solved by this two types of, that is mn. If we multiply two scalars, mn into vector a, m into n into vector a is m into n into vector a. That is just associated, it is a property. Okay, and also 0 into vector a is 0 vector, and 1 into vector a is vector a. That's are the some results. It's the multiplication of vectors by scalars. And next is the most important, very important, two laws has been there. Combination of two directed line segments or addition of vectors. Okay, addition of vectors. How will you add two vectors? That is, or two directed lines. How will you combine two directed lines, segments, or add it? There are two laws there, triangle law and parallelogram law. Okay, those two laws are important. Okay, that is given here. The two, if we have given two vectors, if we combine it, then the third side, it is triangle. You know triangle has three sides. So if we have given two sides, okay, if we have given two sides vectors, okay, then that we can have the third side. That third side is the addition. It is the result of adding that two vectors. Okay, consider a triangle, three sides has been there. The longest side is the side, the largest side. Okay, that largest side is the sum of the remaining two sides, if that vectors. Okay, that is given here. Okay, it is the sum, that is the addition combination. Look at their figure. Vector A and vector B is given. If there is a, yes, if there has been drawn a triangle, okay, vector A, vector B, AO, AB, then if we join OB, that third side, that longest side is the sum of that two vectors, vector A plus vector B. Okay, vector A plus vector B, that is the, yes, that is the triangle law. We can form triangle using two vectors. Yes, the two sides has been given, then that side, the addition, if we combine that, yes, two sides using addition, then that is the third side we have been get. Okay, that is, so we should read plus sign as followed by instead of plus. Okay, we do not, yes, that A followed by B, that is how to be read, how it is to be read. It is not A plus B, it is vector A followed by vector B, that is how to be it is read. Okay, this is the sum of vectors. That is, as definition, if 3 points OA and OAB are so chosen, vector OA and vector AB respectively represents vector A and vector B. Okay, so you know line segments has been drawn from the initial and terminal points. So we have drawn OB, vector OB, line segments. So vector OA or vector AB, that is given, and we represent that two sides as vector A and vector B. Then OB, vector OB is the sum of, it is defined as the sum of vector A and vector B. That is written as C. Vector C is A, vector A followed by vector B, A plus B. Okay, then A plus B is also the resultant of A and B. So this is known as the triangle law of vectors. Okay, I think it is clear. Okay, yes. The next is the parallelogram law. So as per the name, you have to form parallelograms. So how will you form parallelograms? You know parallelograms are, yes, opposite sides are parallel and equal also. So we can draw a diagonal, then we can divide the parallelogram into two triangles. So triangles law has been, you have been studied. According to that, okay, so we have constructing the parallelogram law, parallelogram using vectors. Okay, so completing OABC, we have drawn OAB, triangle OAB. We can complete that triangle, yes, by extending a point C, which may be parallel, which is to be parallel as BC. Okay, BC and OC, that is the two sides we have extended, and which makes that OAB to complete a parallelogram. Okay, so the completing the parallelogram OABC. Okay, so vector OB is vector OA plus vector AB, and also vector OB is vector OC plus vector BC. That is the construction there. Okay, I hope it is clear. Yes, that we have taken first triangle, and then we have extended B to C and O to C. We have just joined that. That is it. That's it. Okay, and since AB, vector AB and vector OC are B, vector B, and vector BC is A. Thus, the result of adding two co-initial vectors is the vector represented by the diagonal of the parallelogram formed with the component vectors as adjacent sides. Okay, so here is we have taken the diagonal. We get the diagonal of the parallelogram, which with the component vectors as adjacent sides. Okay, yes, we have representing the coinitial vectors means the initial point is same for two vectors. So the coinitial vector is the vector which is represented by the diagonal. Okay, and it is a diagonal of the parallelogram formed with the component vectors as adjacent sides. Okay, that is the parallelogram law of addition. Yes, diagonal of the parallelogram is, yes, defined there. Okay, yes, I think it is clear. Okay, the next is position vectors that we have in the previous class. I have just mentioned it, but it is not complete there. Okay, so that's why I have mentioning one more time. So position vectors are, okay, and this vector of same magnitude direction whose starting point is the origin and the terminal point is the point P. That is, the vector OP is the position vector if it should be started from the origin, and vector of P relative to the origin. Position vector is always related according to the origin. Okay, so we have to start that vector from the origin. That is the position vector of a point. Okay, the vector has same magnitude and direction. Vectors has to be same magnitude and direction whose starting point is origin and the ending point is that point P. It may be P or it may be Q, anything else. Okay, that's the position vector. Next is, how will you represent a vector in terms of position vectors? Okay, as its endpoints. And it is just you have to, it is not as much important, but it is using the triangle law. We have just going through it. Okay, that is the vector PQ here. The vector PQ is the position vector of Q minus the position vector of P. Okay, position vector of Q minus position vector of P. That is there. That is, the position vector of P and Q may be vector P and vector Q as the, okay, and respectively, which is, you can you can just go through that pictures figure. Okay, then you will understand it. Okay, P and Q be the vectors PQ, and PQ is the line segment taken, and vector PO plus vector OQ as per the triangle law, and minus P, because yes, minus P plus Q, because yes, OP is in that direction and OQ is in this direction. Okay, so OP is in straight direction, OP is in straight direction. Okay, but we have taken PO, so it may becomes minus P. Okay, that is there, and OQ is Q, and also OQ minus OP. OQ is, yes, minus Q. So minus P plus Q or Q minus P. That is, these two are equal. This shows the position vectors have the same endpoints. Okay, this shows, this is how to express. We have giving the it's minus P plus Q and Q minus P. These two are same. Okay, either PQ, vector PQ is vector OQ minus vector OP, or OQ, vector OQ is OP plus vector OQ, vector PQ, that is given. This is how to express a vector PQ in terms of position vectors OP and OQ of its endpoints. So the position vector of Q minus position vector of Q is vector PQ. That's the result you have to be remembered. Okay, yes. Then next are some examples there. If modulus of the magnitude of vector A is 5, then find 6 into vector A. 6 into means scalar into vector A. That is, vector A is, how will you find? Yes, modulus of 6 into vector A is modulus of 6 into modulus of vector A. Modulus of 6 is 6. 6 into modulus of vector A is 5. So 6 into 5, 30. 530. That is the magnitude. Okay, and likewise the next question. Also, the fifth question is given. That's the second question is, if the sum of two unit vectors is a unit vector, show that the magnitude of the difference is root 3. Unit vectors, you know, yes. Okay, yes, sum is 1 that we have studied. So, the proof is given. Okay, yes. Next are some exercises for you. First question, okay. And next is the unit vectors. vector I cap, it should be, yes, I cap, j cap and k cap. Okay, that's the unit vectors in 3 dimension. 3-dimensional coordinate system you have studied. That's 3-dimensional coordinate system. In that coordinate system, okay, you have just using I, j and k. Okay, and for a position vector, okay, we take any point as origin. Origin as the reference. So in this Cartesian system, we take origin of reference, that is origin as the reference, and we denote unit vectors along x-axis, y-axis and z-axis. Okay, so unit vectors, this is taken as the center. Okay, origin should be the position vectors. Position vectors always has origin as the initial point. So here we have taken, yes, according to that, in Cartesian system also we have taking position vectors. Okay, so from the origin you have taking that unit vectors. So it is from along the x-axis, along the y-axis and along the z-axis we have taken. Okay, so similar, okay, that is, and vector I and vector j. For xy axis, vector I is, the unit vector I cap is in along the x-axis, j cap is along the y-axis, and here in the third 3D system, okay, 3-dimensional system, k cap is in the z-axis, is along the z-axis. Okay, that is ox, oy and oz. This is the non-coplanar unit vectors. Okay, and this system, okay, which contains the unit vectors are called orthonormal system. Such a system is, okay, non-coplanar unit vectors has been defined along the three-dimensional coordinate system. That system is called orthonormal system. Okay, and as position vectors, it is, we can take points in A, X, Y and Z, and we can represent the unit vectors along with the x-axis as OX, OY and OZ. That is AI, BJ, CK. That is along x-axis is AI cap. That means it is along x-axis, and B, J cap along y-axis, C, K cap along z-axis. If it is 2D plane, it is AI, BJ. Okay, just A, B and C are scalars. It has magnitudes like that. Okay, so this is the unit vectors. So in the first figure, the 2-dimensional is given. Second figure, 3-dimensional is given. Okay, this is the unit vectors: I cap, J cap and K cap. Okay. And next is the distance. How will you find the distance of? Okay, that means distance means the sum. That is the component. Okay, the proof is given, just go through that. The component of vector OP along x-axis is a vector xi whose magnitude is modulus of vector x and whose direction is along OX or OX dash according to as x is positive or negative. Okay, OP, the figure OP is given, vector OP is given, it is along the x-axis and it has the vector xi. So that vector has magnitude modulus xi, modulus x, and it is along OX or OY. OX or OY according to the as x is positive or negative. Okay, that is the coordinate plane XOY. It is a 2-dimensional, and OM is given as the point P. Look at that point. Yes, it is a position vector because it starts from the origin. So it is a position vector. So OP is given and OP is drawn. So that is the coordinate XY. Yes, X means it is the point on X, that measure, and Y is the point on Y. You know that, Y axis. Okay, that is given. And if we have taking OM as we have given OM is X and MP is Y, and I and J are the unit vectors. So along OX and OY, so OM, vector OM is XI cap and vector MP is YJ cap. Okay, and the components of component vectors has been taken. That is vector OP is, yes, as per addition triangle law, vector OP is vector OM plus vector MP, that is followed by vector MP. That is OP is XI cap plus YJ cap. That is OP is R cap. We have just taking XI cap plus YJ cap as R. We are just naming it. So OP is, okay, that is OP. That means, yes. And if we square the both sides, you have get R modulus of R cap. That means R is the third position vector OP. Vector OP is R, vector R. And if we square the both sides, we get the magnitude modulus of vector R cap, vector R. Okay, that means the magnitude of the position vector, third side. That is root of x square plus y square. Okay, because if we square I is what? This is the unit vector. I square is 1. Similarly, j square is 1. So, you root of x square plus y square is the answer. So, it is to be remembered. If we take a position vector OP as xi plus yj, then modulus of OP is root of x square plus y square. That the magnitude is root of x square plus y square. I think is it clear? Okay, is it clear? It is clear, okay? Yeah. Next is the component of a vector on a line. It's just component means, okay, vector AB. Just look here. Vector AB make an angle with a given directed line L in an anti-clockwise direction. Then the projection of AB, vector AB on L is the line, and it is the vector whose magnitude is vector modulus of vector AB into modulus of cos theta, and the direction is in the direction of L or opposite to that of L according as cos theta is positive or negative. Okay, so this is the projection. Projection means if we have an vector AB and if it makes an angle theta with a directed line L, a directed line means it has direction in anti-clockwise, that is given there. L is given and vector AB is also given in the first figure. Vector AB is given and L is given. Small l. Look at that, small l. So if it is that means if L is given, I mean if small l, that is the directed line is given, and here that anti-clockwise direction theta is marked. Okay, and then you get the projection. The projection means is the magnitude of vector AB and modulus of cos theta. Okay, modulus of cos theta means theta may be negative or positive according to the sign that is given. Okay, these following figures are just some projection of AB has been given. Okay, yes. Next are some problems. Okay, exercise problems has been given. You have to find some unit vectors parallel to this, like questions has been given. Okay, that is okay. So this is the today's class. This is all for today's class, because you have to just familiar with this topic. In the next class we have adding with the scalar. Okay, that has been given for you, but in the next class we have just going to our next section of vectors. Okay, so you have to be carefully listen to the two classes. Only then only you can just if you are not familiar with vectors, you cannot solve the problems in this chapter. Okay, so you have to be you have to solve problems like this. I mean these problems okay, this type of problems very well. All the questions has been given in your textbook, so you have to work out all those workout, I mean given examples, okay, given examples you have to be solved and work out, okay. And as also the exercise, so many exercise has been given for you. If you feel any doubt, you can ask me, okay. That is many questions has been given. You have to go through this and solve them, okay. Thank you for thank you. And please, I'm just hurrying, as because I have to complete your portions. I'm very back, okay, as in, yes, I'm very back in your according to your syllabus. I'm very back in very back, because I don't know, I haven't know that I have to be I mean complete that whole chapters before the second term, I mean before November, okay. So please cooperate with me, okay. I don't, yes, I am not aware of that, because it's just because of that, okay. So I will be posting more classes on EduPro, so please watch and please cooperate with me, okay. Thank you.